Evaluate the integral. Here we have x squared plus 2x minus 1 over x cubed minus x dx. We want to convert this first to a partial fraction. So before we do that, we want to first factor this out. So we have x squared plus 2x minus 1 in the numerator. Over, if we factor out an x, we have x times x squared minus 1. Okay, which is the same thing as x squared plus 2x minus 1 over x times x plus 1 times x minus 1. Okay, so again, the first thing we need to look at is the fact that the degree in the numerator is smaller than the degree in the denominator, which allows us to be able to see that we can factor out the denominator. We have three things in our denominator that are different. So therefore, this is going to look like the following. A over x plus b over x plus 1 plus c over x minus 1. And now we're going to treat this as an equation. So we're going to multiply each term by the LCD. And the LCD is x times x plus 1 times x minus 1, x times x plus 1 times x minus 1, x times x plus 1 times x minus 1, and the same thing, x times x plus 1 times x minus 1. So we can see here that on the left side of the equation we can eliminate the entire denominator. For this one we can eliminate the x, this one we can eliminate x plus 1, and then this one is x minus 1. So now let's go ahead and write this out. So we have x squared plus 2x minus 1, which is equal to a times x plus 1 times x minus 1, plus b times x minus 1, plus c times x plus 1. Okay, so now let's distribute the a and then multiply everything out. So we have x squared plus 2x minus 1. Over here, we're going to have the difference of squares. So this is a times x squared minus 1, which is the same thing as ax squared minus a. Over here, we're going to distribute the bx to both of those terms. So we have bx squared minus bx plus multiply the cx squared plus cx. Okay, now let's write our systems of equations. So what's the first equation? Well, we can see that the coefficient for x squared is 1. And then we have ax squared plus bx squared plus cx squared. So that means we have a plus b plus c, and that's equal to 1. Let's take a look at our next equation. So we're looking at the coefficients of x. So here we know that this side is 2. The coefficient here is negative 1b, and this one is plus c. So we have negative b plus c, which is equal to 2. And the third one, we have negative a, which is equal to negative 1. Okay, so now we can use that to solve the systems of equations. So if we divide both sides by negative, we know that a is going to equal to 1. So we know that that's already solved for. So the next thing to do is we need to figure out what is b and what is c. So what we're going to do is in equation number 1, we're going to let a equal 1. So it's going to be 1 plus b plus c, which is equal to 1. If we subtract 1 to both sides, then equation 1 is now going to become b plus c is equal to 0. Now let's take a look at equation 2. Equation 2, we have negative b plus c, which is equal to 2. So since we already have the opposites of b, we can eliminate those. We end up getting 2c, which is equal to 2, and therefore c is going to equal 1. And now we got to figure out what b is. So using equation number 2, we have negative b plus c, which is 1, which is equal to 2. Negative b is going to equal 1, and therefore b is going to equal negative 1. And so therefore, there are our coefficients of the new integral. So let's go ahead and write the integral. So again, the question was x squared plus 2x minus 1 divided by x cubed minus x dx. And then we factored it to be the following. So we have a over x plus b over x plus 1 plus c over x minus 1, and that's dx. So now if we plug in a, we know it's 1 over x plus b, which is negative 1 over x plus 1 plus c, which is 1 over x minus 1 dx. And so if we wanted to, we can say, okay, well, we're going to separate these in separate integrals. So 1 over x dx minus the integral, because we factored out the negative here, 1 over x plus 1 dx. And then this is plus the integral of 1 over x minus 1 dx. So the antiderivative of 1 over x is going to be the natural log of the absolute value of x, minus the antiderivative of 1 over x plus 1 is going to be the natural log of the absolute value of x plus 1, plus the antiderivative of 1 over x minus 1 is going to be the natural log of the absolute value of x minus 1, and then that's plus c. So now if we want to condense this logarithm, we're going to bring the plus on this side. So we have the natural log of the absolute value of x plus the natural log of the absolute value of x minus 1 minus the natural log of the absolute value of x plus 1 plus c. Okay, so since this is plus, we can multiply these two together. And so then we end up getting the natural log of the absolute value of x times x minus 1 minus the natural log of the absolute value of x plus 1 plus c. And now we can condense those, so we have one single logarithm where we have the natural log of the absolute value of x times x minus 1 over x plus 1 plus c. And therefore, there is our result.